Hi folks, we're going to take a look at number 28b from page 84. So they give us this function which has an absolute value, and they're asking us to sketch the graph, find the derivative, and determine where the derivative doesn't exist. Okay, so we can actually sketch this graph without writing it as a piecewise function, because we notice this is a quadratic. Okay, now notice it's a quadratic that's going to be shifted downwards. Okay, so essentially it's going to leave everything that's positive positive, and everything that's negative is going to become positive. Okay, so first thing is let's find the zeros of this here, and so we've got 3x squared minus 6 equals 0, so we'll solve for x squared, so that becomes 6 over 3, so 2, so x is plus or minus root 2. Okay, so if we want to sketch the graph, we would start with the original quadratic. Okay, and you notice that everything that's below 0, I'll draw as a dotted line, because these are the values that are going to change. So essentially, we know that all these negative values will just become positive. So the graph will look something like this. That's negative root 2, and that's root 2. And so we can see clearly from the graph that it looks like we've got two cusps here at the zeros. Okay, but if we want to show for sure that these are indeed non-differentiable points, we're going to do that algebraically. So first thing we do is we turn this into a piecewise function. Now here, because there's two changes in sign, we're going to need 3 lines in our piecewise function. Okay, so we're going to have x less than negative root 2. We're going to have x between negative root 2 and positive root 2, and then we're going to have x greater than root 2. Okay, so here in this interval the function is already positive, so nothing changes. Okay, in this interval here though, the values were negative, so we need to make them positive, and we do that by multiplying them by negative 1. And then here again they're positive again, so the y values are not going to be changing. Oops, that should be, of course, 3x squared minus 6. Okay, now we notice that at negative root 2 and root 2, the value of the function is 0, and in any case that's going to give us, so I'll just put them both in the center there, okay, because that'll give me 0. But I could have put the equal sign here and another equal sign there, would have represented the exact same thing. Okay, so if we want to find the derivative of this function, okay, we can just find the derivative of the individual components. Okay, now the only thing you got to keep in mind is that at negative root 2 and root 2, okay, the equation changes on either side, so we're going to have to check to see whether it's actually, the derivative is actually defined at those points. Okay, we already kind of know from the graph that it won't exist. So here, derivative of the first here is just going to be 6x. Okay, so that's for x less than negative root 2. And then we've got, this is just going to be negative 6x. And this is again going to be 6x for x greater than root 2. Okay, so if we want to test the derivative at negative root 2, we need to take it from both sides. Okay, so if I find the derivative at negative root 2, okay, first from the left, okay, so since I'd be approaching with this function, okay, we know that this is the derivative that's going to describe the behavior of the function as I approach negative root 2. So notice here I don't have to put it into limit definition. I've already sort of essentially done that by using my derivative properties. Okay, so this is going to be 6 times negative root 2, which is negative 6 root 2. Whereas when I approach from the right, okay, I'm going to need to use this function here, because as I'm finding the derivative, I'm going to be working with the slopes of the secants from that function from the right. So that's just going to be negative 6 times negative root 2, which of course is going to be 6 root 2, so not equal. So not differentiable. We've proved now that it's not differentiable at negative root 2, and we're going to see something very similar for positive root 2. Here, we're going to use this function here, so negative 6 root 2, whereas if I approach from the right, I need to use that one there, so 6 times root 2, so again, not equal. Okay, so f, we can say, is not differentiable at x equals plus or minus root 2. Okay, but it is differentiable everywhere else. Okay, so again, just a quick recap. In this case here, in order to write this as a piecewise function, we needed 3 different lines because this function changes sign at 2 different locations. So first thing is to determine where those x values are going to be, and then from there determine where you need and don't need to put a negative sign in front of the function. Okay, that's it for this one.